Okay, welcome to section 5.4. We're going to be talking about the sum and difference formulas. So you want to make sure you have these sum and difference formulas available to you. They are on a sheet that I handed out earlier in the year. If not, I will post that also onto Canvas so you can get that sheet as well. Because we're going to use it. We're going to use those sheets. Now, our goal is to find the exact values. But if we look at number 1, all we have is a 75. That's not one of our nice angles. So keep in mind, we have our pi over 6. And pi over 6, that's our 30-degree angle. We have our 45-degree angle, which is pi over 4. And we have our 60-degree angle, which is our pi over 3. Now, the coordinates of those are root 3 over 2, 1/2. Remember, for the pi over 3, we just flip them, 1/2. Root 3 over 2. And for our pi over 4, it's root 2 over 2 and root 2 over 2. Now, we want to get 75 using these values, either a 30, 45, 60. And don't forget we have our quadrant angles, our 90s, our 180s. So our goal is to get 75 using these. So what we can do to get 75 is just add 30 and 45. So we're looking at the cosine of 30 plus 45. Now, that would match us up to this equation, the cosine of u plus v. Now, 30 is our u, 45 is our v. So it's, to find that, it's the cosine of u, or the cosine of 30, times the cosine of v, which is 45, minus the sine of u, which is our 30, times the sine of v, which is 45. Now, cosine, the sine is our y. So the cosine of theta is our x. So the cosine of 30, looking at 30, the cosine is root 3 over 2. The cosine of 45 is root 2 over 2, minus the sine of 30. That is 1/2 times the sine of 45, which is root 2 over 2. So now that we have those values, we got them right from up here from our unit circle. Root 3 over 2 times root 2 over 2. Multiplying the radicals, you get the square root of 3 times 2, which is 6, over 2 times 2, which is 4, minus 1 times root 2 is root 2 over 4. Now, we can't really do a whole lot with this. All we can do is write this with a common denominator of 4, the square root of 6 minus the square root of 2. That's the exact value for the cosine of 75. Now, the decimal value for the cosine of 75 is about 0.259. There's our values, but our goal was to get that exact value. Now we're going to look at the exact value of the sine of 165. Now, 165, I want to use either the 30, the 45, or 60, or the multiples of 30, 45, and 60. Now to get 165, that would be the same as the sine of, now the multiples of 45, 45 times 1 is 45, times 2 is 90, times 3 is 135. And then we have the 30 we can work with. So what we can do is we can do sine of 135 plus 30. Now, for this, we're using the very first one, the sine of u plus v. U is 135, v is 30. So this is going to be the sine of 135 times the cosine of 30 plus the cosine of 135 times the sine of 30. This one's a little bit trickier because the sine of 135, if we think about our unit circle, 135 is in quadrant 2. So that point is at negative root 2 over 2 and positive root 2 over 2. So for our sine of 135, it's root 2 over 2. The cosine of 30 is root 3 over 2. Plus the cosine of 135, that's negative root 2 over 2. And the sine of 30 is 1/2. So now we just multiply. Root 2 over 2 times root 3 over 2, you get the square root of 6 over 4 minus the square root of 2 over 4. So you get the square root of 6 minus the square root of 2 over 4. And that is the sine of 135. That's the exact value. You could look at the decimal equivalent and compare it to when you just do sine of 135 on your calculator. You'll see that they're the same. But like I said, we're looking for this exact value, not a rounded value like the calculator would give us. The sine of pi over 2. Now remember, we're working with our pi over 6, our pi over 4, and our pi over 3. Once again, this one's a little bit trickier. Now, thinking about this, we could add them or we could subtract them. Now, looking at the values we have, you see how we have the 4 pi, or the pi over 4 and the pi over 3? 4 times 3 is 12, so I think I'm going to have to work with these two here. So what we could do is that if we had a 4 pi over 12 and subtracted a 3 pi over 12, that would give us a pi over 12. Now 4 pi over 12, that's pi over 3. 3 pi over 12, that's our pi over 4. So what we have here is pi over 3 minus pi over 4. So the sine of pi over 12 equals the sine of pi over 3 minus pi over 4. Now we're going to go back to the top of the page for the sine of u minus v. U is pi over 3 and v is pi over 4. So it's the sine of pi over 3 cosine of pi over 4 minus the cosine of pi over 3 and the sine of pi over 4. I got that right from above in that sum and difference formula. Now the sine of pi over 3. That's root 3 over 2. The cosine of pi over 4 is root 2 over 2. The cosine of pi over 3, 1/2. And the sine of pi over 4 is root 2 over 2. So we get the square root of 6 over 4 minus the square root of 2 over 4, square root of 6 minus the square root of 2 over 4. That's the exact value of the sine of pi over 12. There's the exact value. And you can compare that to the decimal equivalents. Now, problem number 4. What's nice is we already know that pi over 12 is just pi over 3 minus pi over 4. So the cosine of pi over 12 is equal to the cosine of pi over 3 minus pi over 4. So looking at our sum and difference formulas, here's our u, here's our v. So for the cosine of u minus v, it's cosine of u cosine of v plus the sine of u sine v. So it's the cosine of pi over 3 cosine of pi over 4 plus the sine of pi over 3 cosine of pi over 4. And then we fill in our values. The cosine of pi over 3, 1/2. The cosine of pi over 4 is root 2 over 2. Plus sine of pi over 3, root 3 over 2. And the cosine of pi over 4 is root 2 over 2. So we multiply, we get root 2 over 4 plus root 6 over 4. And we finally got a different answer. We get, for the cosine of pi over 12, our exact answer is root 2 plus square root of 6 over 4. That's our exact value. Let's go to the next page. Now, in the next one, we're kind of working backwards. We have sine, cosine. So we have the sine of u, cosine of v, minus the cosine of u, sine v, where u is the 42 and v is the 12. We're going backwards to say, all right, which one of our sum and difference formulas is sine u cosine v minus cosine u sine v? And if we go back, sine cosine minus cosine sine, that is the sine of u minus v. So what that is the sine of u minus v. So that's the sine of u, which is 42, minus 12. So that's equivalent to the sine of 30. And the sine of 30, if we go back and look, is 1/2. And there's the exact value of that. Now we're going to skip problem number 6, and let's go to problem number 7. We're going to prove the cofunction identity, that the cosine of pi over 2 minus x is equal to the sine of x. We had that earlier on. Now we're going to prove it. So we have is the cosine of u minus v. So for the cosine of u minus v, that's the cosine of u, cosine of v, plus the sine of u times the sine of v. And we're going to fill in our values, the cosine of u. So cosine of pi over 2 times the cosine of x plus the sine of pi over 2 times the sine of x. Now pi over 2 is one of our quadrant angles. It's up here. And that's located at 0, 1. So our cosine is the x. So the cosine of pi over 2 is 0 times the cosine of x. The sine of pi over 2 is our y. It's 1 times the sine of x. And our goal is to see, does it equal the sine of x in the end? 0 times any number is 0, so they cancel out. And 1 times the sine of x, we get the sine of x equals the sine of x. And we just proved that cofunction using our sum and difference formulas. Okay, thank you, and I will see you. We'll do more of these, focusing more on tangents and some others. Have a nice day.